Have you ever wondered what Fibonacci sequence is? Well, in this video, you're gonna learn everything that you need to know about Fibonacci sequence. So, let's start. The famous Fibonacci sequence is named after Leonardo Pisano, also known as Fibonacci, an Italian mathematician who lived from 1170 to 1250. The Fibonacci sequence is a set of numbers that starts with 1 or 0, followed by 1, and proceeds based on the rule that each number, called a Fibonacci number, is equal to the sum of the preceding two numbers. If the Fibonacci sequence is denoted f of n, where n is the first term in the sequence, the following equation obtains for n equals 0, where the first two terms are defined as 0 and 1 by convention. The Fibonacci formula is given as f of n is equal to f of n minus 1 plus f of n minus 2, wherein the f of n is equal to the nth term of the series, while f of n minus 1 and f of n minus 2 are the n minus 1 and n minus 2 terms respectively. Fibonacci numbers are of interest to biologists and physicists because they are frequently observed in various natural objects and phenomena. The branching patterns in trees and leaves, for example, and the distribution of seeds in a raspberry are based on Fibonacci numbers. So, what is the difference between geometric, arithmetic, and Fibonacci sequence? Well, before knowing the difference between the three, let us first define geometric and arithmetic sequence. A geometric sequence is a sequence of numbers in which the ratio between consecutive terms is constant. It is also called as geometric progressions, where it has a formula of a of n is equal to a r n, where r stands for the common ratio between the successive terms. For example, 1, 2, 4, 8, 16, 32, 64, 128, 256. This sequence has a factor of 2 between each number. Each term except the first term is found by multiplying the previous term by 2. An arithmetic progression, on the other hand, has the first term as a and a common difference between the term and the next, not by adding successive terms. An example of arithmetic progression is 1, 3, 5, 7, 9, wherein the common difference between the terms is 2. The main difference between the three is that in geometric sequence, the ratio between the two terms is constant. In arithmetic sequence, there is a common difference for each term in the set of elements, while in the Fibonacci sequence, the next number from the first number was added up to the next number. One important note: do not get confused with series and sequence. Remember that an itemized collection of elements in which repetitions of any sort is allowed is known as sequence, whereas series is the sum of all the elements in a set of terms. Now, to put Fibonacci sequence in a better light, let's have some examples. Example number 1. The question is, find the next number in the Fibonacci series. 0, 1, 1, 2, 3, 5, 8, 13. Well, the Fibonacci formula is given as f of n is equal to f of n minus 1 plus f of n minus 2, wherein n is equal to 9. So the solution goes like this. F of 9 is equal to f of 8 plus f of 7. After that, f of 9 is equal to 13 plus 8, meaning f of 9 is equal to 21. The next number in the Fibonacci series is 21. How about Fibonacci sequence in real life? Well, we can see it in our nature. Considering the number of the petals of the flowers, some of them follow the Fibonacci numbers. One possible reason for why this phenomenon happens is that they try to decrease the overlapped area to get more sunlight. The hidden Fibonacci spiral in sunflowers is a great example of this phenomenon. We can also see Fibonacci sequence on the organs of the human body. Humans exhibit Fibonacci characteristics. Every human have two hands. Each one of these hands have 5 fingers, and each fingers has 3 parts which are separated by 2 knuckles. All of these numbers fit into the sequence. Moreover, the length of bones in a hand are in Fibonacci numbers. The Fibonacci sequence of numbers is greatly manifested in music widely. The numbers are present in the octave, the foundational unit of melody and harmony. Stradivarius used these sequences to make the greatest string instruments ever created.